In this video, I want to show you a little bit more about something called a perfect square trinomial. We did talk about this earlier in the section. We were talking about factoring perfect squares, but the reason we're talking about it more in detail right now is because the next process for solving quadratic equations that I want to show you involves this idea. So we've talked about one method so far, that's solving equation by factoring. The next method I want to show you is solving by something called completing the square. So the first thing we need to do is understand what is a perfect square. And in terms of numbers, you can see on the left side right here, these are all perfect squares. 1, 4, 9, 16. Perfect square just means you take a number and you multiply it by itself. When it comes to a binomial, this is called a binomial because it has two terms. It has an x and a 3. Okay, first of all, when you're actually squaring this, the common mistake that people make is to do the following. They say, okay, well, x plus 3, when I square it, that's going to be x squared, and then 3 squared would be 9. And that's actually wrong, and I'll show you why. First of all, when you square something, it means you multiply something by itself. So we're going to do x plus 3 times x plus 3. If we FOIL this, we'd have x times x, which is that. We'd have the outside terms x times 3, which is this. Inside terms would be x times 3 again, which is this. And then finally 3 times 3 would be 9. And now if we combine these, 3x plus 3x would give us 6x. Okay, so for right now, all I want you to do is try to pause this video and see if you can FOIL out these bottom three as well. And then when you're ready, press play again and I'll show you something important about the pattern here. Okay, so hopefully you had a chance when you to FOIL these out. When you do FOIL these, this one turns out to be x squared minus 8x plus 16. This one turns out to be x squared plus 10x plus 25. And this last one turns out to be x squared minus 20x plus 100. Here's the key idea, and here's what I want you to understand before we talk about completing the square. All perfect squares, all perfect square trinomials, and these four that we just did, I'll number them right here, these four that we just did are all perfect squares because we got these answers right here by taking a binomial and squaring it. Here's the pattern that every single perfect square has in common. If you take this middle number right here, and by the middle number I mean the b value, because remember when we write something in standard form, b is the number that's attached to x to the first. So in this case b is 6. If you take half of 6, you would get 3. And if you square 3, you get 9. Let's see if that pattern holds here. So if I take half of negative 8, I would get negative 4. And if I square negative 4, I do get 16. Same thing right here. If I take half of 10, I would get 5, and if I square 5, I would get 25. Finally, if I take half of negative 20, I would get negative 10. If I square negative 10, I do get 100. So the pattern that every perfect square has in common is that this last number right here, the c value, because c is the thing that doesn't have an x attached to it, the c value you can always get by taking half of this number and then squaring it. So with that in mind, let's practice that process that we just made right there, by the way, is called completing the square. That's what it means. You take half the middle number, you square it to get the last number. Let's do that right now for each of these. So what we'll do is fill in that missing number that will make it a perfect square, and then we'll factor it into a perfect square. Okay, so what do? We need to take half of that number, which is negative 12, and then we square it to get 144. This is now a perfect square. What does that factor to? What numbers multiply to positive 144 and add to negative 24? That would be negative 12 times negative 12. Okay, so that's what it factors to, and we can write this a little bit more compactly like that right there, because really what we're doing here, if we're multiplying something by itself, that means we're squaring it. Same idea right here. Let's take half of that number, which is 1, and then we'll square it to get 1. So this would now factor to r plus 1 times r plus 1, or a faster way to write that is r plus 1, the whole thing squared. Okay, try these other two, pause it and see if you can do them, and then press play for the answer. Alright, so right here we're going to take half of negative 28, which is negative 14, and we'll square negative 14 to get positive 196. Okay, this will then factor to x minus 14 times itself, or another way of saying that is x minus 14 squared. This one's a little bit trickier because we don't have a nice even number like we had before, but we'll do the same thing. Half of 7 is 7 halves, or 7 over 2. And I recommend that you keep it as 7 over 2. Don't change it to a decimal. It's going to make it harder when you have to square it. So how do you square a fraction? Just do the top squared. 7 squared is 49, and the bottom squared, 2 squared, is 4. This is now a perfect square. What does that factor to? It factors to p plus, and then half of this number is what goes here. So half of 7 is 7 over 2. That's now a perfect square. In the next video, I'm going to show you how to use that process to actually solve a problem using what's called completing the square.